How your phone knows exactly where you are. You open a map on your phone. Within seconds, a small blue dot appears showing your exact location. Not just the city. Often the exact street. Sometimes even the side of the road. And all of this works almost instantly, almost anywhere on Earth. So how does your phone actually know where it is? Is it talking to satellites? Is it using the internet? Is there some kind of tracking system involved? The real answer is surprisingly elegant. GPS is basically a giant system of satellites and clocks working together to measure distance with extreme precision. So today we're going to unpack how GPS works and how that tiny blue dot appears on your screen. Chapter 1: What GPS actually is. GPS stands for Global Positioning System. It's a network of satellites orbiting Earth that allows devices to determine their position. The system was originally developed by the United States for military navigation. But it eventually became available for civilian use and is now built into phones, cars, airplanes, and ships. The full system includes three main parts. Satellites in space. Ground stations that monitor those satellites. And receivers in devices like your phone. Your phone doesn't send signals to GPS satellites. Instead, it listens to them. The satellites are constantly broadcasting information about their position and the time the signal was sent. Your device uses that information to figure out where it is. Chapter 2: The satellites orbiting Earth. There are more than 30 GPS satellites orbiting Earth at any given time. They travel roughly 20,000 kilometers above the planet. Each satellite circles Earth about twice per day. Their orbits are carefully arranged so that several satellites are always visible from almost any location on Earth. This constant coverage is essential, because your device needs signals from multiple satellites to determine your location accurately. Each satellite contains extremely precise atomic clocks. These clocks keep time with incredible accuracy, which turns out to be the key to the entire system. Chapter 3: GPS is really about measuring distance. The core idea behind GPS is simple. If you know how far you are from a satellite, you know you are somewhere on a sphere around that satellite. If you know your distance from two satellites, your position narrows down to where those spheres intersect. Add a third satellite, and your location becomes much more precise. With signals from 4 satellites, your device can determine your exact position on Earth. Latitude, longitude, altitude. All calculated by measuring distances from satellites. And those distances are determined using time. Chapter 4: Time is the secret ingredient. Remember those atomic clocks on the satellites. Every GPS signal includes a timestamp showing exactly when the signal was sent. Your phone receives the signal and compares that time with the current time on its own clock. Because radio signals travel at the speed of light, the time difference reveals how far the signal traveled. For example, if a signal took 1/10 of a second to arrive, the receiver knows the signal traveled about 30,000 kilometers. That distance tells your device how far away the satellite is. Once it knows the distance to several satellites, it calculates your position through geometry. This process is called trilateration. Chapter 5: Why 4 satellites are needed. In theory, 3 satellites could determine a location. But in practice, GPS uses 4. The reason is clock accuracy. Your phone's internal clock is not nearly as precise as the atomic clocks in satellites. A 4th satellite helps correct tiny timing errors. Even a tiny timing error of 1/1,000,000th of a second could create position errors of hundreds of meters. So the system uses multiple satellites to refine the calculation. The result is a very accurate position. usually within a few meters. Chapter 6: Why GPS works almost everywhere. One reason GPS feels so reliable is because satellites cover the entire planet. Whether you're in a city, on a highway, or hiking in the mountains, satellites are overhead. As long as your device can receive signals from several satellites, it can determine your location. However, obstacles can interfere with signals. Tall buildings, dense forests, tunnels, indoor environments. These can weaken or block signals temporarily. That's why GPS sometimes struggles indoors or in urban areas with very tall buildings. Chapter 7: GPS and your phone. Modern smartphones combine GPS with other technologies to improve accuracy. They may use cellular towers and Wi-Fi networks to estimate your position more quickly. This helps when GPS signals are weak or still being acquired. Once the phone locks onto satellites, GPS provides the precise location. Your map application then uses that location along with map data to show your position and calculate routes. So the navigation you see on your screen is really two systems working together. Positioning from GPS and mapping software to interpret it. Chapter 8: GPS is used everywhere. GPS is used for far more than navigation apps. Airplanes rely on GPS for navigation and landing procedures. Ships use it for global positioning across oceans. Farmers use it to guide automated agricultural equipment. Construction companies use it to measure land precisely. Financial networks even use GPS timing signals to synchronize transactions. The system quietly supports large parts of modern infrastructure. Most of the time we only notice it when our phone tells us where the nearest coffee shop is. But the technology behind that simple feature is surprisingly sophisticated. In summary, GPS is a global system of satellites that allows devices to determine their position on Earth. Satellites orbit the planet while broadcasting their location and precise time signals. Your device receives signals from multiple satellites and calculates how far away they are. By measuring distances from at least 4 satellites, your device determines your location using trilateration. Atomic clocks make the timing accurate enough for precise distance measurements. Modern devices combine GPS with Wi-Fi and cellular data to improve speed and reliability. The result is a positioning system that works almost anywhere on Earth. All powered by satellites and very precise timing. GPS feels effortless because the complexity happens behind the scenes. Satellites, atomic clocks, and geometry quietly working together so your phone can show a tiny blue dot on a map. Once you see the system behind it, the technology becomes less mysterious and a lot more impressive. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. See you in the next one.